Today I'm going to tell you a story about the life of LHC proton beams. Our story starts with this bottle of hydrogen gas. A hydrogen atom is composed of a proton and an electron. First, we need to strip off the electrons of hydrogen atoms in order to get protons. This is done by the metal cylinder called the plasmatron in this figure. Then the protons are injected into LINAC 2 and accelerated to the energy of 50 mega electron volts. In particle physics, the energy is measured in the unit of electron volts. The protons cross the LINAC 2 and reach the proton synchrotron booster, or PSB. PSB is a circular 4-ring accelerator with a diameter of 50 meters. The PSB booster accelerates the protons to 1.4 giga electron volt, or JeV. In contrast, the beamline from the LINAC 2 to the PSB is about 80 meters. So this basically tells us the linear collider is impractical to be used to accelerate particles to high energy. These protons are then transferred into proton synchrotron, or PS, and further accelerated to 25 JeV. The PS is also responsible for providing benches to the LHC with 25 nanosecond spacing. In the LHC, the protons in beams are not homogeneously distributed. Instead, they are clustered into so-called benches. In each bench, there are about 115 billion protons, which is about 100 times the Chinese population. The 25 nanosecond spacing in time can be converted to the distance between two adjacent benches. We can just simply multiply 25 nanoseconds by the speed of light, which gives us 7.5 meters. That is, the distance between two adjacent benches in the LHC is 7.5 meters. Okay, let's return to PS. And the benches of protons are then injected to super proton synchrotron, or SPS. And the SPS accelerates those protons to 450 JeV. According to Einstein's special relativity, this means that the proton is about 450 times heavier than the proton at rest and is traveling at almost the speed of light. Finally, the proton reach the LHC and they are separated into two beams circulating in the opposite directions. At the beginning, they need to be accelerated to a still higher energy. The designed energy of the LHC is 7 tera electron volts. That is, a proton in the LHC beam is about 7,000 times heavier than the proton at rest. The beam are circulating at almost the speed of light for about 10 hours, which is called the beam life. Within this beam life, the protons may have different lives. The two beams traveling in the opposite direction are manipulated to encounter at each other at 4 different places, where the ALICE, ATLAS, OSB, and CMS experiments locate. Hence, the protons have the chance to collide with each other. The collisions most probably destroys the colliding protons and produce some new particles. However, some protons may also miss the chance to collide with other protons. After 10 hours of beam collisions, the beam itself is exhausted and leftover protons are dumped by the LHC dumping system at point 6 as shown in this figure. The leftover protons are then transferred to an external absorber. So we have to say, sorry guys, you missed the chance to contribute to the science. Okay, so this is the end of today's story, and thank you for watching this video.